First, we will enter the name of the flavor and the date. Then, let's return to the recipe. The top graph corresponds to the composition of the product. This is the information that will appear on your label. We can see at first glance that the composition fits well into the circular framework, except for the emulsifier dosage. The bottom graph analyzes the structure and allows to anticipate certain aspects of the resulting texture. It reads from the top, then clockwise. In the present case, we can see a deficient structure in several points, despite a standard composition. The parameters 1 and 2 illustrate the composition quantitatively, which means the dry part, but also qualitatively, which refers to the density of the ice cream. There is therefore nothing to report on this side. Then comes the emulsifier that we will dose based on the work of Goff and Hartel. We consider here a blend with an usual ratio of emulsifier to stabilizer of 60 to 40. We then adjust the stabilizer dosage and selection depending on its molar mass and desired viscosity. We will now look at the parameters 3, 4, and 5, which focus on the fat network, both quantitatively, meaning the unctuosity, but also qualitatively, regarding the smoothness and the anticipation of the product's melting rate. We want to keep around 9.5% fat in our final ice cream, so we will replace some of the egg yolks with fat with high melting point, in this case, cocoa butter for example. Note that the parameters 5 and 6 allow us to anticipate the mix's viscosity. Continuing our reading of the graph, we find the parameters 7, 8, 9, and 10, which provide information on the aqueous phase and the optimization of the milk solids not fat. In our case, it is apparent that these values are close to the upper limit. Now let's move towards the milk solids not fat optimization cell, which will be our guide in this correction. This formula is sourced from the Dairy Science Journal. So, we still need to improve the parameters 11, 12, and 13, which illustrate the balance between the scoopability and the sugar content, and which must be balanced as a whole, and this is done according to the customer's taste and the service temperature. Here we will consider a product that should be scoopable at minus 18 degrees Celsius and a relative sweetness around 18. We are looking for the suitable combination of sugars in order to solve this double constraint. We can also take this opportunity to refine the dry part and round out the recipe to reach an exact total. Finally, we can edit and save this recipe in a PDF format, which will allow us to compare several recipes swiftly.